We will continue our looks at past AP questions by looking at the 2016 free response question number 1 for BC. This is a question that involves a combination of an equation and a table, and it's again interpreting rates. Water is pumped into a tank at a rate modeled by this equation, and it's removed from a tank modeled by this chart. And there are 50,000 liters in the tank at the beginning of our scenario. All right, question 1. Estimate R prime of 2. All right, well, R happens to be the table here. So how do we estimate R prime of 2? Well, remember, R prime's a slope, so we're looking for the slope of this. So what values do you want to pick where we're going to estimate 2? I'm just going to say we might as well pick these two, because what's right smack dab in the middle of 1 and 3? Yeah, 2. So how about we do that? So we will just take the slope of that. 950 minus 1190 over 3 minus 1, which is negative 240 over 2, which is negative 120. Now it does want units. So remember, our top unit here is liters per hour, and our bottom unit is hours. So you could leave it like that, or you could write it negative 120 liters per hours squared. Alrighty, let's go on. I left Riemann sum with the 4 subintervals. Alright, so the idea is, visually, we have got this table. 1, 2, 3, 4, 5, 6, 7, 8. Now, I'm not going to be exact with it because I don't need to be. But the first interval goes from 0 to 1. And if we're doing a left endpoint, it means the left side of the box is the height. And then the next one goes from 1 to 3, and it's a little lower. Whoops. Trying to draw a gray box. There we go. The next one goes from 3 to 6, a much wider box, and we started at 950, which again is a little lower. And our last box is 2 units wide, and it's 740 feet. 40 feet, geez, 740 liters per hour. All right, so we kind of have a graph that looks like this. Again, I was just visualizing it so I could take a look at what the graph would look like. So the graph would look something like this. All right. Again, just a visual interpretation of it. Now let's just figure out the Riemann sum. So what we would get is, if we would go from 0 to 8 of the Riemann, we'll just call it R. Well, I mean, because we're talking about the rate of this. So it's approximately equal to the height of the first box, which is 1340, times the width, which is 1 unit long, plus the 1190 height times 2, because it's 2 units long, plus this one's 3 units long, and its height is 950. I'm going to run a room here, so I am going to see if I can slide all this over. Almost. Alright, and my last box has a height of 740, and it is 2 units long. Alright, doing a little calculation there, we just come up with the fact that this would equal 8,050 liters. Alright, so that's the amount of water which was removed from the tank. Then the question becomes, is this an over or an underestimate? Well, because it's left Riemann sum and the function is decreasing, you can tell the function is decreasing not by looking at the graph per se, but by looking at the chart. Since the function is decreasing, it's an overestimate. So if it's an overestimate, because R of t is decreasing. Alrighty, very good. Next question. So we're going to use that answer of part B. What was our answer? I don't want to forget. 8,050. All right, let me put that in there so I don't forget. To find an estimate of the total water in the tank to the nearest liter at the end of the 8 hours. So we got to consider it all. What's going in, what's coming out, what did it start with? So the total would be about the water coming in. And there's 8 hours. So from 0 to 8 of this equation. Minus the water coming out, which we've already calculated, plus the what was there to begin with. It was 50,000 to start. All right. Again, it's a calculator-driven question, so you won't have that on this year's test. But you plug this thing into your calculator to find the antiderivative, and you will get, and let me see, we're doing an approximation, right? So it's just an estimate. So it's really 7,836.19. So I think we just leave it like that. We're just estimating it. Okay. Minus, well, we already figured that one. That was my 8050. Plus 50,000 to start. All right, which means that we put all that together, we're going to get 49,786 liters. All right. Last one. Is there a time when the rate at which the water is pumped out into the tank is the same as the rate for which is being removed from the tank? And it's a very interesting question. It's intuitive in a way that you can kind of see why the answer is true, but the thing is you have to explain why or why not, so we've got to use calculus words. So basically the question is this. Does the rate of the water being pumped into the tank ever equal the rate of it leaving? Oops, I don't know why I put another equal sign there. Is that ever true? Okay, well, we're basically thinking this, aren't we? Well, here's what I thought about. Okay. I've already graphed this. I already know what this kind of looks like, but I'm going to plug in 0 for W, and I'm going to find out that I start with 2,000. Now, if I find W of 8, I find that that's 81.524. Now then, think about it logically. If I'm starting at 2,000 and I'm going down to 81, is that going to cross this that starts at 1340 and goes down to 700? Yeah, it's got to. It's got to. There's 3 conditions. Okay, condition number 1. W of 0 is bigger than R of 0. And W of 8 is less than R of 8. Now we know that they cross each other because they are both continuous graphs. There's no gaps or holes. So remember this little thing we used to call IVT, the intermediate value theorem? In the interval. And that, ladies and gentlemen, is that. That is the 2016 question number 1 BC. Hope you guys have a great day and keep on keeping on. I really have no idea what that means.